Hi everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today I want to discuss about some of the problems on surface integral. So in the previous video, we discussed about what is the surface integral and what is the formula for that, how we can evaluate that surface integral. So here we are going to see some of the examples or some of the problems to evaluate the surface integral. So just I want to give the outlines for the formula and definition. So here the definition of the surface integral: an integral which is to be evaluated over the surface. So here we are evaluating the integral over the surface is called surface integral. So here this is the formula. The surface integral formula is double integral over S f bar dot n bar ds. So here what is the f bar? So f bar is f1i, f2j plus f3k, and n bar is outward unit normal vector. So here for the ds we are going to select about the planes xy plane or yz plane or zx plane based on the problem which is possible. We can observe the formulas here to calculate the ds and for the unit normal. So here we are taking the continuous function f of r and a surface S, and n is a unit normal to the surface at any point. So now integral S, integral over S f dot n ds is normal surface integral or surface integral of f of r over S. So here just now I told you about the planes. We can select xy plane or yz plane or zx plane. So if you are taking the projection of the surface on xy plane, so we are going to use this formula, that is ds equal to dx dy by det of n dot k. So you can remember this one very easily. How we can remember already we discussed in the previous video. If you want, once go to that. So see here for the xy plane we are using the formula for the ds is dx dy by n dot k, and for the yz plane ds is dy dz by det of n dot I, and for the zx plane is ds equal to dz dx by n dot j. So these are the values or formulas we are going to use for the ds for the projection of the surface on xy plane, yz plane and zx plane. And here one more value we need to know to evaluate the integral here. So that is n. What is the n? N is the unit normal to the surface, that is capital N equal to del pi by det of del pi. So we can indicate the capital N as like this, small n cap also. So both are same, there is no difference. So in the problem they will give f bar, that is nothing but the vector, and n we can calculate by using the formula del pi by det of del pi. And for the ds, so if you selecting the xy plane we are using this formula, if you are selecting the yz plane we are using this formula, if you are taking zx plane we are using this formula. So these formulas are very important. Without these we can't do the problem by to evaluate the integral here. See the example. Evaluate double integral over S f bar dot n ds. So here we have to evaluate this integral. So what is the f for the given here? F bar equal to x plus y square into I bar minus 2x j bar plus 2yz k bar. So this is the vector. This is the vector, f bar vector, and S is the surface. S is the surface of the plane. What is that plane? 2x plus y plus 2z equal to 6. So the given plane also here, that is 2x plus y plus 2z equal to 6 in the first octant. This is the given problem. So here to evaluate this integral, that is double integral over S f bar dot n ds, here we should know about the f bar. and we should know about the n, we should know about the ds, then only we can evaluate this integral. So to knowing these values, in the problem they give an f bar. F bar is x plus y square into I, 2xj plus 2yzk, and they given plane here. So what is that plane? 2x plus y plus 2z equal to 6. And we have to know about the limits over the surface. So because of that, they given here first octant. In the first octant means we can take x, y and z values from 0. Why we are taking 0 here means first octant means nothing but this is the first quadrant. So we are taking as all values are positive here. So here we can take all values are positive means starting from 0. So this is the way to analyze the problem first. After analyzing the problem, we can go to the solution here. So first I am writing the given data. What is the given data? Given f bar equal to x plus y square into I bar plus minus 2xj plus 2yz into k bar. So here they given pi also plane. So let here I am taking this one as a pi equal to 2x plus y plus 2z minus 6. So this is the pi. So here we have to evaluate. What is that value? Double integral over s f bar dot n bar ds. This value we are going to evaluate. So for that, first we should know about the n. Already f is given. So what is the formula for the n? N equal to del pi by det of del pi. Del pi by det of del pi. That means we should know about the del pi value. After then we can calculate the n here. That's why first we are calculating the del pi here. So now we are calculating the del pi. Del pi equal to pi is given here 2x plus y plus 2z minus 6. This is the given pi. So now we are calculating the del pi to evaluate the n value. So del pi is nothing but I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So this is the value. So I have to calculate dou pi by dou x, dou pi by dou y and dou pi by dou z. Then I can replace here. So first of all pi equal to 2x plus y plus 2z minus 6. Now I am calculating dou pi by dou x. That means I am doing the partial differentiation with respect to x. Dou pi by dou x means partial differentiation of pi with respect to x. So with respect to x, when I am doing with respect to x, y and z both are constants. So here 2 differentiation of x is 1 plus here when I am doing with respect to x, y is the constant. So there is no other values also. That means constant, derivative of constant is 0 plus 2 is also constant and z is also constant. So derivative of constant is 0. Minus here 6 also constant. This value is 0. So finally I got 2. Dou pi by dou x value is 2. Next dou pi by dou y value. Dou pi by dou y value means here partial differentiation of pi with respect to y. So now I am doing with respect to y. So when I am doing with respect to y, x and z both are constants. So here 2 and x both are constant here. So this value is 0. Plus y differentiation is 1. So this value is 1. Now plus here 2z both are constant. So the derivative is 0. Here 6 also constant. This derivative is 0. So finally dou pi by dou y value is 1. Dou pi by dou y value is 1. Now we are doing dou pi by dou z. I am doing here pi with respect to z. So here 2 and x, when I am doing with respect to z, x and y both are constant. So here x, y, z, 3 variables are there. If I am doing with respect to x, remaining 2 are constant. If I am doing with respect to y, remaining 2 are constant. If I am doing with respect to z, remaining 2 are constant. As like this we have to treat when you are doing the partial differentiation. So already you learned this partial differentiation in before. So you have to remember this formulas for the differentiation and partial differentiation. So here dou pi by dou z. So with respect to z, I am doing x and y both are constant. So 2 and x both are constant. So first term is 0. And y also constant. Second term also 0. Here plus 2 into derivative of z is 1 minus 0. Finally this value is 2. Now I got dou pi by dou x value is 2. Dou pi by dou x value is 2, dou pi by dou y value is 1 and dou pi by dou z value is 2. So I am replacing here I dou pi by dou x value is 2 plus j dou pi by dou y value is 1 plus k dou pi by dou z value is 2. So finally 2i plus j plus 2k. So this is the value of del pi. For the n value, n equal to del pi by det of del pi. So del pi value what I got here 2i plus 1j plus 2k, and det of value is nothing but square root of quotients of I, j, k. So 2 square plus 1 square plus 2 square. So finally this is 2i plus j plus 2k by square root 2 square is 4 plus 1 plus 4. Finally this is 9. So this value is 2i plus j plus 2k by square root 9. So what is the square root 9 value is 3. So finally n equal to 2i plus j plus 2k by 3. This is the value of n. This is the value of n. So in the integral value we calculated n value. So already we know the f value. So after that we can calculate the f dot n value. Now we are going to calculate f bar dot n bar. So f bar already we are having here x plus y square into I minus 2x into j plus 2yz into k. This is the f bar value. Dot n value is 2i plus j plus 2k by 3. So we are doing here f bar dot n bar or capital N bar, both are same. So here we are doing dot product, means I dot I is 1, j dot j is 1, k dot k is 1. So in that way we are doing here x plus y square into I quotient here, this is 2 by 3. This is 2 by 3. Next minus 2x into j quotient, that is 1 by 3, sorry, here 1 by 3. Next plus 2yz into this is 2 by 3. Now we are going to simplify this one. 2x plus 2y square by 3 minus 2x by 3 plus 2yz into 2, that is 4yz by 3. So finally I am simplifying this. 2x plus 2y square minus 2x plus 4yz by 3. So plus 2x minus 2x will be cancelled. Here I got 2y square plus 4yz. So from this I am taking the common 2. I am getting here y square minus, plus here y square plus yz, 2yz, 2 I am taking common. So remaining 2 by 3. So that is all you can observe here, 2 by 3 y square plus 2yz. So if you want you can take the common of y also. So here we are simplifying this one, 2 by 3, and we are taking the common y. So finally this is y plus 2z, y plus 2z. So now we are going to use the some plane value. So already we know what is the plane pi equal to 2x plus 5 plus 2z minus 6. So from this we can write the y plus 2z value, right? So y plus 2z value we can write it as 6 minus 2x minus, so in place of 2z also we can write or y plus 2z also, both are same. Now that one we are using here. So 2 by 3 y into y plus 2z value, where we taken from 5, 2x plus y plus 2z minus 6. So from this we can write the 2z value, that is 6 minus 2x minus y, that is only we replaced here. Now plus y minus y will be cancelled. Finally we got here 6 minus 2x. Here also 2 is common, we can take 2 by 3 y into, take the 2 common, 2 3s are 6, so 3 minus x, 3 minus x. This is the final value, 4 by 3 y into 3 minus x. This is the value of f bar dot n bar. So f bar dot n bar. Now I got the f bar dot n bar value. If you know the ds and if you know the limits, we can finalize the answer. So now for that, in integral over s, f bar dot n ds. In this one, f bar dot n is already calculated. So to evaluate this integral, we should know about the ds now. So which one projection we are taking here? Based on that, we can take the formula. Here, let R be a projection of S on the xy plane. And one more important point here, we can select any plane xy or yz or zx. According to that, we should know about the limits of those xyz. Then only can evaluate the integral. In some of the problems, they will give the values of y and z. That means you can yz very easily, because already they given the limits or values of the y or z. So based on the problem, we have to decide about the plane. Okay, I hope you understand about the projection. So let R be the projection of S on xy plane. Here I am taking the xy plane. If I take the xy plane, what is the formula for the ds? ds equal to dx dy by det of n dot k. Det of n dot k. So here already I know the n value. What is the n value? 2i plus j plus 2k by 3. This is the n value, but I don't know about the n dot k. So now I am evaluating, or I am calculating here n bar dot k bar. So n dot k bar is here first 2i plus j plus 2k by 3 dot k bar. So here already we know about the dot product. I dot I is 1, j dot j is 1, and k dot k is 1. But if it is interchange, that means I dot j is 0, j dot k is 0, I dot k is 0. So that's why remaining, if it is values are changed here, we'll get the 0. If both are same, and that means I dot I, j dot j, k dot k, both are, the 3 values are 1. So according to that, first I dot k term is 0, j dot k term is 0. Next third one, 2 by 3, k dot k is 1. So finally I got here 2 by 3. That is the value of n dot k. That is the value of n dot k. So now I am going to evaluate the integral. So double integral over s, f bar dot n ds equal to double integral over s, f bar dot n. In place of ds, we are replacing the formula dx dy by n dot k. So now we are going to replace values of this now. So here double integral over r, I am taking the region here over r. So now here f bar dot n bar, what I got for the f bar dot n bar? Here 4 by 3 y into 3 minus x. That is only we are replacing 4 by 3 y into 3 minus x. F bar dot n bar value is 4 by 3 y into 3 minus x, and ds formula is here dx dy by, here already we calculated n dot k. So n dot k value is 2 by 3. That is only we are replacing here. So double integral over r 4 by 3 y into 3 minus x into dx dy by 2 by 3. 2 by 3. So now we are simplifying this one. Double integral over r 4 by 3 y into 3 minus x into dy dx, and this 2 by 3 is we are written as 3 by 2. So 3 will be cancelled, 2 2s are 4. Finally I got here double integral over r 2 into y into 3 minus x into dy dx. 3 minus x into dy dx. That is only we are seeing here. So now we should know about the limits of y and x. Then we can integrate this value. I want to take the limits now. Here I am taking y and x. I should know about the x and y limit, then only I can evaluate the integral. So what is the plane? The given plane equal to 2x plus y plus 2z minus 6. Otherwise equal to 6. So here I am considering the xy plane. I am considering the xy plane, right? So on xy plane, what is the z value? Z value is 0. Then 2x plus y equal to 6. From this I am going to write the y limits first. So y equal to 6 minus 2x. Y equal to 6 minus 2x. So already in the problem, they given this plane is in the first octant. First octant means all values are positive. So that means y is from 0. From starting value is 0. So y equal to 0 to y equal to 6 minus 2x. So if you are taking here y equal to 0, what is the x value? 2x equal to 6, x equal to 3. X equal to 3. So these are the x and y limits. Otherwise, you can take x as the variable and y as the constant. Both are same. You can take these limits also. Otherwise, you can take x as variable and y as constant. How it is, you can see here. So here on xy plane, z is 0 means 2x plus y equal to 6. I am writing here 2x equal to 6 minus y. So x equal to 6 minus y by 2. So already I told you, they given in the problem, this is in the first octant. First octant means all values are positive. That means, so x value also starting from 0. So x equal to 0 to x equal to 6 minus y by 2. This is only they taken here. X values are 0 to 6 minus y by 2. Next, if x is 0, what is the y value? Y equal to 6. So y also starting from 0 here. So now these are the limits. X limits are 0 to x equal to 6 minus y by 2, y equal to 0 to 6. So if you know the limits, we can integrate the function here. So now the function 2, here integral y limits. What are the constant we have to take at the last? So 0 to 6. Integral 0 to, these are the x limits, x equal to 0 to 6 minus y by 2. And we are having here y into 3 minus x into dx dy, dx dy. If you are taking y variable, then you can write dy dx. Okay, so here 2 integral 0 to 6. So now we are doing the integration with respect to x. So x limits are 0 to 6 minus y by 2, right? So 3y, both are constant, right? So here integral dx is x, limits are 0 to 6 minus y by 2, 6 minus y by 2 minus integral x dx. Integral x dx is x square by 2, limits are 0 to 6 minus y by 2. So that is only we are simplifying here. So 3x. So we are taking constant. So 3x minus x square by 2, limits are 0 to 6 minus y by 2. Now we are replacing the limits here. 2 integral 0 to 6. 3y into x limits are 6 minus y by 2. Minus 0 means this value is 6 minus y by 2. Minus here 1 by 2 taking out. So x square into, so in place of x we have to replace, right? So here 6 minus y whole square by 4 minus 0. So finally this is 2 integral 0 to 6. So we have to simplify this equation. So here 6 minus y is the common, right? So here 6 minus y by 2 taking common. So 3y minus 1 by 2. Here this one is 6 minus y by 2. 6 minus y by 2. When you are simplifying this, we are getting the value here. 1 by 2 into 18y minus 3y square minus 1 by 8, 6 minus y whole square. So when you are simplifying this, now I can do the integration with respect to y now. So here 18 integral y is y square by 2 and integral y square is y cube by 3. So here when you are simplifying, you can simplify this, otherwise you can do the as it is here, because this is the constant, you will get the same integration. So 6 minus y whole square means, already we know the formula, integral x power n is x power n plus 1 by n plus 1. According to this formula only we are using here. So integral y square is y cube by 3. Here integral 6 minus y square is 6 minus y whole cube by 3 plus 1. So here 3, when you are replacing the value here, we are getting 0 to 6. Limits are 0 to 6. Now we are simplifying this and replacing the limits. So 9 into 6 whole square minus 6 whole cube plus 1 by 12 into 0 here, when you are substituting that value. So we are getting 0 here. This is upper limit minus lower limit. Lower limit is 0. So when you are having the y, you can replace the 0. So first term is 0, second term also 0, plus third term also. Here 1 by 12 into, in place of y 0 means constant value will be there. So 6 cube. So finally when you are simplifying this, you are getting the 81. You are getting the 81. What is this value? Double integral over s f bar dot n bar ds value. So this is the way we can evaluate the surface integral by using the plane, projection of the plane. We'll discuss one more problem to get the better clarity. I hope we understand this problem. So to get the better understanding, I am moving to one more example. So see here, show that integral over s yzi plus zxj plus xyk dot n ds is 3 by 8. That means, so this value should we have to show 3 by 8. So based on the where S is the surface of the sphere, what is the sphere? X square plus y square plus z square equal to 1 in the first octant. As like a previous problem, the given this one is that plane is in the first octant. So here this sphere is in the first octant. So first octant means all values are positive. We have to remember this one. And here they given the sphere, instead of plane they given sphere. They can give cylinder also, they can give sphere also, they can give plane also, whatever it may be. We have to take the projection of xy plane or yz plane or zx plane. So here we are they given here the sphere, we are taking that one as pi equal to x square plus y square plus z square minus 1. And what is the f bar here? Actually in the previous problem directly they given the f bar. So, but in this question they given here f bar dot n bar we have to evaluate, right? So, in place of f bar they given value, that is yz I plus zxj plus xyk. So, that's why this inner meaning is nothing but f bar. So, now we are taking given data in the solution. So, here given that f bar is yz I plus zxj plus xyk. Next, we are taking the sphere, that is as a pi. So pi equal to x square plus y square plus z square minus 1. So as like a previous problem, we have to evaluate f bar dot n bar ds. So what is the n bar? N bar is unit normal. We have to calculate del pi by delta of del pi. This procedure you have to be in your fingertips. Then it will be very easy. Otherwise these problems are very lengthy. If you are taking step by step, it will take so much time. That's why you have to understand the steps and you have to know about this step. Then we can do the calculation very fastly. So here n equal to del pi. Del pi means you have to evaluate this del pi here. What is the del pi? Del pi formula is I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So what is the pi here? X square plus y square plus z square minus 1. So here we are calculating dou pi by dou x and dou pi by dou y, dou pi by dou z. So here pi equal to x square plus y square plus z square minus 1. So dou pi by dou x value, what is the dou pi by dou x value? With respect to x we are doing, x square is 2x. So y square is 0 because that is the constant. Z square also 0 and this is also 0. Finally this is 2x. So 2xi. Next dou pi by dou y. What is the dou pi by dou y? With respect to y, x is 0. So this is 0. With respect to y, y square is 2y. and with respect to z, that is 0. So finally this value is 2y. Next, in the same way for the dou pi by dou z. Dou pi by dou z. What is the dou pi by dou z? With respect to x, this x square term is 0, y square term is 0, and z square is 2z. Z square is 2z. So 2xi plus 2yj plus 2zk. This is the del pi. Now we are going to calculate the det of del pi value to evaluate the n. So what is the det of del pi value? Square root of 4x square plus 4y square plus 4z square. So here when you are simplifying, we are getting here 2. So when you are taking 2 out, so already we are having x square plus y square plus z square equal to 1. So that means this value is 2. So n cap equal to del pi by det of del pi. What is the del pi here? 2 into xi plus yj plus zk by 2. This is the n value. Now we are calculating f bar dot n value. So this is the f bar. Yzi plus xzj plus xyk. So now here xi plus yz plus zk, when you are doing here, I dot I is 1, j dot j is 1, k dot k is 1. So according to that, we are calculating f bar dot n bar value is 3xyz. So now I know this value, f bar dot n value. Remaining I have to know about the ds. That means which plane we are going to consider. So here we are taking, let R be the projection of S on xy plane. R be the projection of S on xy plane. So on xy plane the formula is dx dy by det of n cap k. So already I know the n value. We are going to calculate n dot k also. So n value is xi plus yj plus zk dot k. So I dot k is 0. J dot k is 0. So finally z into k dot k is 1. So finally this value is z. So n dot k value is z. Now I am writing, or I am going to evaluate the integral. Double integral over s. F bar dot n cap ds equal to double integral over, or I am taking the r is in here. F bar dot n cap into, in place of ds I am writing the formula dx dy by det of n dot k. So double integral 3xyz. So dx dy, this value is already calculated z, that is z. So z and z will be cancelled. Finally I got here double integral 3xy dx dy. Now I should know about the limits. Then I can evaluate this integral. So here from the given plane, given sphere, x square plus y square plus z square equal to 1. So here I am considering xy plane. Xy plane means, so z value is 0. Xy plane means z value is 0. So x square plus y square equal to 1. X square plus y square equal to 1. Now from this I can take the x as variable, otherwise y as variable. So if x is the variable, y will be constant. If y is the variable, x will be constant. So you can take anyone. So here we are taking x varies from 0 to square root 1 minus y square. So that means here x square equal to 1 minus y square. So x equal to square root 1 minus y square. So x limits are from 0 to y. We are taking 0 here means already we given in the problem first octant. So that means all values are positive. That's why we are taking both values from 0. So x is varies from 0 to square root 1 minus y square. And y varies from 0 to 1. That means here x is 0 means y value is y square equal to 1, that is y equal to plus or minus 1, all positive values. So that's why we are taking y limits are 0 to 1. Now I am writing the limits. So integral y limits are 0 to 1, x limits are 0 to square root 1 minus y square. So f dot n value is 3xy. F dot n value is 3xy. I am writing here 3xy into dx dy. Now 3 is the constant, taking out integral 0 to 6. And here I am doing the integration with respect to x first, because here x is varying. So y is the constant. Integral x dx is x square by 2. Limits are 0 to square root 1 minus y square into dy. Now I am replacing the limits y as it is. So x square means square root 1 minus y square whole square. We got 1 minus y square, and this 2 is taking out, so constant. So 3 by 2 is the constant. So y minus y cube I can take. Now I am doing integration with respect to y. So 3 by 2 integral 0 to 1 y dy minus integral 0 to 1 y cube dy. Now I am writing this 3 by 2 integral y is y square by 2, limits are 0 to 1, minus integral y cube is y power 4 by 4, limits are 0 to 1. So now I am replacing the limits. So 3 by 2 and 2 into 2 is 4, so 3 by 4, y square is 1 square minus 0, minus here 3 by 8. So here 1 power 4 minus 0. Finally 3 by 2 into 1 by 2 minus 1 by 4. Finally I got 3 by 8. So here double integral over s f bar dot n bar ds value is 3 by 8. So this is the procedure to evaluate the surface integral. I hope you got the better understanding and better clarity about these surface integral problems. So if you want, you can go through these references. I used here the textbook of engineering mathematics written by IKV Iyengar, and engineering mathematics written by B.S. Gravel. If you want, you can use the B.V. Ramana also. And here I used some of the Google links and the materials. You can go through that materials also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.